Okay, so finding intercepts. We've been talking all about like straight lines, right? Y equals mx plus b. We know a fair bit about straight lines and that kind of thing on graphs. And turns out another thing about lines that's really important is where they cross the axes. We call these intercepts. And not just straight lines, all kinds of relationships. We're going to look at a few other different kinds of relationships in this course. And so finding intercepts is a really important thing. We're going to use them a little bit to graph as well. But it's really the algebra of finding them that I think is the most important thing. And we're going to do some activities later this week where we practice this again. And it's going to be useful to be able to graph with the intercepts just because it'll be nice and fast. Okay, and it's pretty easy math. We use 0, so it's pretty easy math. Okay, but we're going to set it up in a very specific way, and I think if you kind of get on board with that, you'll find this is actually pretty easy. And if you do it again, if you set it up the same way that I'm going to recommend, then you'll remember it later. Before we get started, I want to talk about something about what intercepts are, what you should know about them, what you should understand about them. Again, that will help you not just be successful today, but remember tomorrow when you come back to class and later this week and next week that you can also remember this. Some people are good at remembering things for 24 hours and then forget. So how do you get your memory to last longer, right? So this might help a little bit. So just watch. You don't have to write this down. Okay, just watch. So there's our line. Where is the y-intercept? This is y, this is x. Where's the y-intercept? It's where it crosses the y-axis. So here it is here. And what is true at that point, no matter where that line crosses the y-axis, what's true at that point? Well, what's true is that x is 0. The whole point is you haven't gone to the left, you haven't gone to the right, you've stayed on the axis. Does that make sense? So where I go left or right, we call that x. It's a measurement of how far you've gone. If you go 0, in other words, if x is 0, you haven't gone anywhere, you're on that line. Does that make sense? Seems simple, but it's actually there's actually more going on there maybe than we previously thought about. So same thing for an x-intercept. What do we know? Y is 0. I haven't gone up, I haven't gone down, I've stayed on the axis. Right? The axis is like the starting point, it's where it's 0. And then this point here is where both are 0, right? We call that the origin. And so if y is 0, I don't go up, I don't go down, I'm on the axis. And I want you to really think about that and like take a moment. So this is where you can do some learning on your own. Really think about that. Because if you can remember that, and I want you to write this down. You don't have to write down all of this stuff, but I want you to write this down. The x-intercept occurs when y is 0. So write that down. And the y-intercept occurs when x is 0. And you don't want to just memorize that. You want it to click. You want to get it. You want to visualize that graph. If x is 0, x is a measurement of how far you've gone left or right. I haven't gone left or right because x is 0. So I'm on that y line. What if y is 0? Then I'm on the x line because I haven't gone up, I haven't gone down. So you don't like memorize this. It just makes sense. And if I ask you in June, hey, can you find me an x-intercept? You would say, well, what does that mean? Oh, if it's an x-intercept, it's on the x-axis. What do I know about that point? I know y is 0. You know what I mean? You can kind of figure it out. You can reason your way through it. Okay? So everybody got that written down? You can write down the first question. We're going to find both the x and y intercepts of each of the lines we're going to look at here. And again, I am going to ask you to kind of write it a very specific way, but the reason is because it's going to help you remember how to do this. Okay, and we're going to really, this is a quick process. It's not a lot of writing, but in order to do it properly, we kind of need to we still do need to show our work. So we're going to write this, y-intercept at x equals 0. We're going to write this every time we find a y-intercept, we're going to write that tiny little statement. That's also going to save us a bunch of work in the end, so it's worth writing. And if you write it every time, when you come into class tomorrow or next week, you'll remember. Y-intercept, oh yeah, y-intercept occurs when x equals 0. X-intercept occurs when y equals 0. And it's not very often that people make a mistake and say, like, X-intercept occurs when x equals 0. People don't often do that. They know that you kind of flip it. And like I said, this is probably a lot of you are going to find this really easy today. But it's tomorrow when you walk in to do the learning goal. Can you still do it? And so then I'm going to say, well, what's that statement? Because if you can write this, the rest will follow. Right? This is all you have to remember, and you'll probably be able to figure out the rest. So here we go. If x equals 0, that means there's x plus 2y equals 10, but x is 0. And if x is 0, that whole part's gone, and I'm left with 2y equals 10. And how do I solve this? Very nice. Divide each side by 2. And that gives me y equals 5. But and then my last statement, I'm just going to interpret. Like, look at how easy that was, right? Really easy math. And it doesn't get any harder. It's basically the same every time. And I'm going to go, therefore, x equals 0, y equals 5. I'm going to say that in my head. X, then y. It's alphabetical. Don't get those order mixed up. And take a look. This is really cool. Our answer is already written on the page. X equals 0, y equals 5. So people sometimes do flip them, but not if you're careful, because you've already written the answer basically down. X equals 0, y equals 5 when you show your work this way. Very famous question in math classes, why are we learning this, why are we learning this? Well, remember when we did solving like simple equations? We learned that because now we need that skill in order to do this. Does that make sense? Like, now you know how to solve 2y equals 10. You did probably in grade 9 as well before you came into this course, but right? Like, that's why we do it, because now we're using that skill. Okay, let's do the next one. So this is y equals 0. So instead of y, and again, this is a skill, right? Is substituting and then solving. That's another skill that we've practiced a little bit in this course. So it's 2 times y, but y is 0. So I put 0 in for y instead. And then I solve, and this one's even easier. What's 2 times 0? 0. So that part's gone. And I just get x equals 10. I'm done already. Therefore, and we always write this point down, okay? Can't skip that step. That's my solution right there. Got that okay? Okay, I want you to try again with this one. Follow the exact same steps, write it the exact same way, please. Give it a try. So I've set both mine up. Again, take a look. Like in one case, I'm subbing in for x, and the other case, I'm subbing in for y. Right? So I put brackets for x if I'm subbing in for x, brackets for y if I'm subbing in for y. Kind of neat to see the difference between those two. But in every case, I'm always putting 0 in. So I put 0 in for x, or I put 0 in for y. 3 times 0, 0. And this one's already done. Therefore, x equals 0, y equals -9. 3 times x plus 0 is just 3x equals -9. And what do? Divide both sides by 3. And x equals -9 divided by 3 is -3. So x is -3 and y is 0. And what did I find? Well, I found 2 points. 0, -9, and -3, 0. Right, I found 2 points, and they're both, one's on the y-axis because it's the y-intercept, the other's on the x-axis because it's the x-intercept. And we're going to do a little bit of graphing later on with this, where it's a really good idea to visualize that it's 2 points. Some people take this and they try to put it into 1 point, so it's like -3 and -9 together. No, they're each 2 points. One's on the x-axis, one's on the y-axis. Keep that in mind. Try to think, while you're doing this, try to think of what it is that you're doing as well. It really, really helps. Any questions so far? Did everybody get that okay? Okay, so as long as you've got that and you're on board, we're going to even shorten this process a tiny little bit. But then you're not allowed to shorten it anymore. So what these two examples explain what we're doing, and I would, when you start the practice that you're going to do on your own, I would do it this way at first, showing that substitution. You know what I mean by showing the substitution? So you're showing that 0 goes in for y. It replaces the y. Right? That's what we mean by showing the substitution. So, but the whole point of this process is that we do this quickly, that we're quickly finding intercepts that are important and getting a couple of points quickly. So if I so just watch for a minute. I start with the same title. Okay, you have to do this because otherwise it won't be clear what you're doing. So you got to write y-intercept at x equals 0, or even y-intercept comma x equals 0 is good enough. Okay, and if x is 0, that means this part's going to be gone. 2 times 0 is 0, gone. Isn't that right? So instead of even showing the substitution, you can just write that part of the equation as long as you understand where it comes from. So what we did was we skipped this part, 2 times 0 plus. Okay, we're not even bothering with that because the whole point is we know that's going to disappear because it's 0. And then divide by 4, and I get y equals 3, therefore 0, 3. And again, you have to write the point. Okay, so it's like 1, 2, 3, 4 steps. You can't make it shorter, but it's a little bit less writing than that last example. We're going to do that next. Very good. And then how is this the same and how is it different? If y is 0, this part's going to be gone, right? And I'm going to be left with 2x equals 12. But you got to make sure you understand you're subbing in for y. That's why the y is gone. So you have to write, like you have to think and you have to write this line so you know what to get rid of. Otherwise, people think they're finding the x-intercept. Okay, they might get rid of the x or something. I don't know. Whereas you're getting rid of y. So you do have to be a little bit careful, but we're going to practice. And then divide by 2, x equals 6, therefore 6, 0. It's an intercept. So one of the coordinates is always 0, and the other one is often a number. That's not 0. Okay, try D. And you can always show the substitution if you want. If you prefer to just do it the way we were doing it in the first two examples, you can keep doing it that way. But if you want to skip that part, as long as you understand it, that's good. we're almost done. So if x is 0, then the the x part's gone, and I get negative 4y equals 6. And if the y part is 0, then it's gone, and I get 3x equals 6, right? So that part of it just disappears, and I'm left with a simple little equation that I can solve. This one, I divide both sides by 3, and I get x equals 2, therefore 2, therefore 2, 0. And this one, something a little bit different happens. So I divide both sides by negative 4, right? And some people say, oh, well, wait a minute, I got a decimal. Are you allowed to get decimals? Well, yeah, a decimal is a number. It's a little bit harder to work with in some cases, but they are numbers. They can happen as answers. Always, like that can always happen, or a fraction or whatever. If you're being asked to graph it, probably wouldn't expect a decimal as an answer because they're hard to graph. So that might mean you made a mistake or misunderstood something. But for this, it certainly can happen. So this ends up being y equals negative 6 over 4. And I can do a few things with this. I can divide the top and bottom both by 2. That's called reducing. Or some of you probably did this, 1.5. And there's nothing wrong with that answer because I didn't have to round it. I didn't do anything weird with it. 3 over 2 is 1.5, negative 1.5. I don't think there's a lot of answers that work out to be decimals. But yes, absolutely can happen. Any questions about that? I'm going to show you one more little thing. You don't have to write this next part down, but you do need to watch. Unless there's any questions. Okay, we're only going to do one of these. So again, y-intercept at x equals 0. So the x part's gone. I get 4y equals 8. Divide by 4, y equals 2. X-intercept at y equals 0. The y part is now gone. And what am I left with? 2x equals 8. Divide by 2. X is 4. What can I do with these 2 points? We talked about this before. I can graph them. So 0, left, right, up 2. 4 to the right, up, down, 0. Right? Y is 0. I'm not going up. I'm not going down. I'm right on the line. Again, we're finding intercepts. So every time you should have 2 points. One's on the y-axis. One's on the x-axis. That was the whole point of what we were trying to do. And part of the practice that you see if you look at the handout that I gave you is that you are graphing these. So you plot the 2 points and draw a line with your ruler between them. Okay? So, and this will be helpful tomorrow to allow us to do something else very quickly. Any questions? Okay, I want you to get started. So question number 1, you have to do on your own sheet of paper. And you could do a couple of those to practice if you want. Or you could actually, if you just want to start working on that sheet, you can do question 2. Did I give you the wrong sheet? Oh, I gave you guys the wrong sheet. That's what happened. Okay, so I'm going to collect that. Sorry, it's a different handout. Looks kind of the same. That's why I got them mixed up. So question number 2 is you do it right on here, and you have to plot the points and draw a line. You can do that one first if you want, okay, and then do the other ones after. You can do those in your book. And it's a little bit tight, but I think most of you will be able to squeeze the work in here, so you can do that if you want.